Hey chemistry students, Mr. Resentis again. We're talking calorimetry and we're in chapter 12. So turn to page 396 in your book, thereabouts. We're working problems that are listed in your book, and we're under the category, and we're explaining what a calorimeter is, because we use a calorimeter to study calorimetry. Calorimetry is the science of measuring heat. Now, the calorimeter, if you remember from class, is we used a coffee cup calorimeter, which is just a styrofoam cup, and it contained some water, a thermometer. And then what we did was we put a heated substance, some heated metal, and the change in temperature of the metal, that heat energy from the metal, then was transferred to the water. And so we could measure that energy, because energy can't be created or destroyed, it's really just transferred. So that heat energy is transferred to the water, and we measure that with a change in temperature, all right? And we call that change in temperature delta T, right? So we put some hot metal in here, the temperature changes, that's delta T. We know the mass of the metal, and we could find some information such as the specific heat of the metal. We could also find information such as the heat capacity, and the heat capacity is the amount of energy necessary to raise it 1 degree, raise the temperature of that substance, of that metal, 1 degree. All right? So the calorimeter is a tool that we use to study calorimetry, and the equation that we use to study our calorimetry is the Q equals MCAT. And Q is the heat energy, and we could turn this heat energy into delta H, which is enthalpy. But I'm getting ahead of myself. Let me just go through the equation. The M, of course, stands for mass. The mass of the substance, whether it's the water or the mass of the metal, depending on which it is that we're looking for, which of the heat energy we're looking for. So C is the specific heat of that substance. And so it's found on a table, it's a constant, and for example, we said water was 4.18. Delta T, delta just means change, and T means temperature. And these temperatures, of course, are in Celsius, and it's the change in temperature. The temperature final minus the temperature initial. So that's for determining Q, or the heat energy. If you know the heat energy but you don't know the specific heat, which will be something you'll have to do for a metal in our class, you take that heat energy, maybe the heat energy that you got from the water, because you know the mass of the water, you know the change in temperature of the water, and you know the C value from water, you know the specific heat of water is 4.18, so you know everything except for C of that metal. And so you could put it into this equation. All I did was rearrange it. As you could see, I've isolated specific heat. So we take the heat energy divided by the mass times the change in temperature. So these are the two equations that you'll need to use here in chapter 12, studying calorimetry. Okay, so here's our first equation. When 13.7 gram sample of solid lead nitrate dissolves in 85 grams of water in a calorimeter, the temperature drops from 23 to 19 degrees Celsius. Calculate the delta H for the solution process. Well, first of all, the solution process is the sum of both of these masses. So that's our first. The mass of the solution equals 13.7 plus 85. All right, so that's going to be 98.7 grams. That is the mass of the solution. All right, so now that we have mass, what else do we need for our equation? Q equals m cat. What else do we need for it? Well, we need C. Well, the C value for water is 4.18, and those are joules per gram to degrees Celsius. And these are grams. Then what else do we need? We need change in temperature, don't we? Well, change in temperature, it drops from 2, so it's 19.7, that's temperature final, minus 23.4, so that's our delta T. So we have the 3 components, so we can solve for the 4th component. So our first step, of course, is to get the heat energy in this, and so in order to get this heat energy, you just multiply 98.7, and if you want to know the units, look up there, times the C, which is 4.18, and if you want to know the units, they're right here, and we multiply that by 23.4 minus 19.7, and just plug it into the calculator just like that, and you get 1526. Now those are going to be joules. The Celsius will cancel, and you'll get joules. All right. Now what we want to know is we want to know what the delta H is for the lead nitrate when it dissolves. So what we have to do is we have to find out how many moles. So step 1 was to determine Q, and so here we are. We're determining Q. We're determining the heat energy. Now that we have the joules, what we're going to do next is we're going to divide divide those joules by the moles. All right. So let's find the moles. 13.7 grams of lead nitrate, and we divide that by the gram formula mass. Gram formula mass is 331.2 grams, and if you look up on your periodic table, I think it's 207, 14 times 2, because there's 2 of those, and then 16 times 3, 16 times 6, my apologies, and that's where the 331 comes from. And so that's to 1 mole, so the grams cancel, and we end with moles, right? So that gives us 0.041 moles, which makes sense, because 13 grams is such a small amount considering 1 mole is 300. So as I said, we're going to take this and divide by this. All right. So when we take the 1526, and then we divide by the number of moles, 0.041, we get 37 kilojoules. All right. So that is our delta H. Okay. So we divided our joules by our moles, and we got our delta H. These units those would be positive, right? So now let's try the next one. What is the specific heat of aluminum? The temperature of a 28-gram sample of aluminum increased by 8 degrees C when 207 joules of heat was added. All right. Well, we have a mass, don't we? And that is 28.4 grams. We have a delta T. Our delta T is 8.1 degrees C. That's the change in temperature. It's given for us. And we know the Q value because it's 207 joules, all right? So what is C? Well, for C, what we're going to have to do is we're going to have to use this equation, all right? C equals Q divided by mass times temperature. So if we just take the 207 my apologies, those are of course joules, and we divide that by our mass, which is 28.4 grams, times the change in temperature, then that will give us the specific heat, which is unique for all materials. This will be only the specific heat for aluminum. Here's the specific heat for water. Okay. This is just for aluminum. So when we work this, when I work this, you put this into the calculator. Make sure you put parentheses around this, or else it'll divide by the first number, then multiply. The answer is 0.9 joules per gram degrees C. Right? That's a G. Right? So 0.9 is the specific heat of aluminium. Right?